No, that shouldn't be empty. Let's see. That's the first reaction everyone had when the data appeared. Because when you scan a structure, especially one that's supposed to be solid, you expect resistance. You expect density. You expect something to push back. This scan didn't. It passed straight through. For a long time, the Great Pyramid felt finished. Measured. Mapped. Studied so thoroughly that most people assumed there was nothing left to find. Not because it was simple, but because it was familiar. And familiarity makes us careless. Cosmic rays are constantly passing through everything around us. Through buildings, through bridges, through mountains, through your body right now. We don't notice them because they don't interact much with empty space. But when they hit solid material, they weaken. And that change is measurable. That's why engineers use them. Not to hunt mysteries. To verify structure. The expectation was straightforward. Granite where granite should be. Limestone where limestone should be. A predictable internal profile that matched decades of models and diagrams. Instead, the data showed something behaving like nothing at first. No one reacted. Because the first assumption is always error. Bad alignment. Background noise. Calibration drift. The kinds of problems that disappear the moment you rerun the scan. So they ran it again. The result didn't change. They adjusted angles, changed equipment, shifted timing. The kind of cross-checking that normally resolves anomalies within minutes. Same result. That's when the conversation slowed down. Not excitement. Not panic. Silence. Because engineers don't get nervous when something looks strange. They get nervous when something looks wrong in a way that shouldn't be possible. Here's why this mattered immediately. The empty region wasn't near the edges. It wasn't where stress relief cavities usually appear. It wasn't scattered or irregular. It occupied a clean, continuous volume above one of the most carefully engineered passages in the entire pyramid. The Grand Gallery. Think about that. This structure has survived thousands of years. Earthquakes, erosion, time itself. And inside it, there is a place where stone should be doing work, but isn't. Few scanned a modern skyscraper and found a clean absence exactly where the load should be highest. You wouldn't call that a curiosity. You'd call it a serious problem. That's why this discovery didn't explode into headlines right away. Because no one wanted to be wrong about something this basic. They kept scanning. Again and again. Again and again. The void didn't collapse. It didn't change shape. It didn't behave like damage. It behaved like it was planned. And that's where the questions start piling up. Because if this space was intentional, it wasn't carved later. It had to be accounted for before the surrounding stone was placed. Which means someone decided that leaving nothing here was more important than filling it with stone. That decision is harder to explain than any hidden chamber. And we're only at the beginning. The next thing everyone wanted to know was simple, but uncomfortable. How big is it? Because size changes everything. A small gap can be dismissed. A large one forces explanations. And when they started estimating the volume of this empty space, the numbers didn't stay small for long. This wasn't a crack. It wasn't a pocket. It wasn't a minor irregularity you could wave away with geology or construction noise. It's stretched. It's extended. It occupied a region large enough that its absence should have affected the structure if it wasn't intentional. And yet the pyramid stood exactly as it always had. That's the first real contradiction. A structure this old, built of stone this heavy, should not tolerate missing mass without consequence. Not unless that absence was already part of the plan. So naturally, the next assumption was that this space must have had a purpose we already understand. Something familiar, just misplaced in our mental model. People suggested burial chambers, but burial chambers are accessible by design. They leave traces, doorways, passages, debris. This space had none of that. Others suggested construction voids. Temporary gaps left to ease building, later sealed or forgotten. But temporary gaps don't stay this clean. They don't remain stable for thousands of years without reinforcement. And they don't appear exactly where stress calculations would matter most. Another idea surfaced quietly. That this was damage. Something collapsed internally long ago, leaving a hollow behind. That explanation died quickly. Collapses leave signatures. Broken edges rubble. Irregular geometry. This space had smooth boundaries. Consistent shape. It looked less like failure and more like restraint, too, which is a strange word to associate with a monument known for excess. The Great Pyramid wasn't shy with stone. It didn't cut corners. It didn't save material. If anything, it overbuilt. So the idea that its builders suddenly became careless in one critical location doesn't hold up. Here's where the discomfort deepens. When engineers study structures, they don't just look at what's present. They look at load paths, how weight moves, how force travels, where pressure accumulates and where it's relieved. And the position of this void doesn't interrupt those paths. It respects them. The empty space sits in a location that allows weight to flow around it. Like water around a rock. No, not fighting the structure, but cooperating with it. That behavior is not accidental. If you've ever seen how modern buildings are designed in earthquake zones, this should feel familiar. Engineers intentionally include spaces that aren't meant to be used. Gaps that exist purely to absorb stress, to redirect force, to prevent catastrophic failure. We usually don't notice them because they're hidden behind walls and ceilings. Now imagine discovering something like that inside a structure built thousands of years ago. That's why the conversation shifted again. This stopped being about hidden rooms. It became about design philosophy. Because if this void was structural, not functional, then the pyramid wasn't just built to stand. It was built to endure scenarios we don't usually associate with ancient construction. And that raises an uncomfortable question. What were they planning for? Not daily use. Not ceremony. Not burial alone. Those needs don't require this level of internal complexity. Planning for rare events does. Modern infrastructure is full of this logic. Systems designed not for everyday life, but for moments we hope never arrive. Backup supports. Sacrificial elements. Invisible features that only matter when everything else fails. The Great Pyramid has always been described as static, immutable, frozen in time. This discovery suggests something very different. It suggests anticipation. Anticipation implies memory. Because you don't prepare for something unless you've seen it before or been told about it by someone who has. That thought sits uncomfortably, so it's often ignored. But it doesn't go away just because we don't like it. The next step in the investigation made it harder to ignore. They compared this void to known internal features. Relief chambers, corridors, known cavities. None of them matched. Not in shape. Not in position. Not in behavior. This space wasn't connected to anything we know. It didn't invite exploration. It resisted it. And that's the moment when the question quietly changes. Not, what is it? But why is it empty at all? Because empty space, when used deliberately, is one of the most powerful tools an engineer has. And it's not something you stumble into by accident. We're still not at the explanation yet. But at this point, one thing is already clear. Whatever this void is, It was never meant to be found by someone looking for rooms. It was meant to exist whether anyone ever noticed it or not. And that makes it more important, not less. That realization is what carried this investigation forward. Beyond comfort, and into territory most people would rather avoid. Once that realization sets in, the investigation changes tone again. Up to this point, it was still possible to argue about interpretation, about models, about assumptions. But now, the focus shifted to something more basic. Intent. Because structures don't accidentally behave this well. When engineers talk about intention, they're not talking about symbolism or belief. They're talking about choices that show up in outcomes. Choices that only make sense if someone understood consequences ahead of time. And this void keeps doing something very specific. It avoids becoming a weakness. That's important. Because most people imagine empty space as fragile, as something that invites collapse. But that's only true when it's placed without care. Words carved where it shouldn't be. This space isn't like that. Its boundaries are consistent. Its position respects the geometry around it. And most telling of all, it doesn't show signs of stress damage along its edges. No cracking. No deformation. No slow failure. It's as if the surrounding stone expected it to be there. That observation triggered a comparison that made a lot of people uneasy. Shears in modern engineering. When you see this kind of behavior, you're usually looking at a structure designed to deal with extremes, not average loads, not everyday conditions, but rare, high-impact events. The kind of events you don't write about on walls. You prepare for them quietly. So the obvious question became unavoidable. This void is part of a system meant to manage extreme forces. What forces were those? Earthquakes are the easy answer. Egypt isn't immune to seismic activity, and ancient builders were not ignorant of tremors. But the geometry here doesn't fully align with known earthquake mitigation patterns. Some stress directions are addressed. Others are ignored. That selective logic suggests a different priority. Then there's temperature. Expansion and contraction over centuries. Stone reacting to heat, cold, and time. But again, the location of this void doesn't fully support that explanation. Temperature stress is usually handled closer to surfaces, not deep inside the core. Water pressure comes up next. Subterranean moisture. Groundwater movement. But a pyramid sits on bedrock that doesn't behave that way. And there's no evidence this void was ever meant to channel anything. Each familiar explanation gets close, but never quite lands, which leaves an uncomfortable gap in our understanding. And gaps, as we're learning, matter. At this stage, the investigation reached a point where speculation had to be handled carefully, because once you start talking about intent without a clear category to place it in, people tend to jump to extremes. That's not helpful. So instead, the team focused on what the data could say without interpretation. The void has no access points. That matters more than it sounds. Because access points are invitations. They imply use. They imply maintenance. They imply human presence. This space implies none of that. It was never meant to be entered. Not during construction. Not afterward. Not ever. That single fact eliminates a wide range of possibilities. You don't design inaccessible space unless its function doesn't involve people at all. That's a hard idea to sit with, because it reframes the pyramid from a place meant to be used to a system meant to operate. And systems don't need witnesses, they just need to work. This is where comparisons to modern infrastructure become unavoidable. We hide things today for the same reason ancient builders might have. Not because they're secret, but because interference would make them fail. Think about the parts of modern cities you never see. Shock absorbers in bridges, structural voids and skyscrapers, safety margins designed to be boring, invisible, and untouched. No one celebrates those. But without them, things fall apart. Now imagine discovering that same mindset embedded deep inside a structure we've spent centuries describing as ceremonial. That contradiction is heavy. It suggests that the pyramid was never just a symbol. It was also a response. A piece of applied knowledge shaped by something the builders took seriously enough to plan around. And that brings us to a point where history and engineering start to pull in opposite directions. History wants stories, names, purposes we recognize. Engineering only cares about results. And the result here is a void that behaves like it belongs. Viz, which means the question "why is it empty?" may be the wrong one. The better question might be, what happens if it isn't? Because if filling this space would make the structure worse, not better, then emptiness isn't a flaw. It's the solution. And solutions usually come from experience. That's the thought that keeps following this discovery around. Not loudly. Quietly. Waiting for the next piece of data to either confirm it or force us to rethink everything again. At this point, the investigation crossed a line that's hard to walk back from. Because once you accept that the void is intentional and structural, you're forced to confront something deeper than architecture. You're forced to confront mindset. Structures reflect how their builders think about the future. Most ancient monuments are built for presence, for visibility, for memory. They announce themselves. They invite attention. This one hides one of its most important features, where no one was ever supposed to look. That choice alone separates this void from almost every other known feature inside the pyramid. And it leads to a realization that feels uncomfortable the longer you sit with it. This wasn't built to be understood later. It was built to function then. When engineers model structures today, they don't just simulate average conditions, they run extreme scenarios. Worst cases, forces that might only appear once in centuries, but when they do, failure is not an option. That way of thinking is considered modern. Yet here it is, carved into stone thousands of years ago. The pyramid doesn't just resist gravity, it manages it. It redirects it. You can see it in the density data. You can see it in how the surrounding stone behaves. The absence doesn't weaken the structure. It stabilizes it. That's not intuitive. It runs against the way most people think about strength. But engineers know better. Strength isn't always about adding more material. Sometimes it's about knowing where not to put it. That kind of restraint doesn't come from guesswork. It comes from experience. Which raises a quiet question that no one rushes to answer. Experience of what? Not everyday wear. Not seasonal change. Not ordinary stress. Those don't require this level of foresight. This starts to feel like planning for something rare. Something infrequent enough that you don't build monuments to remember it, but serious enough that you design around it. In modern terms, think about backup systems that are never meant to activate. Emergency features that only matter when everything else fails. If they work, no one ever notices them. If they don't, everyone does. The void inside the pyramid fits that logic disturbingly well. It doesn't demand use. It demands absence. No text praising the inside of its designers. No records that say, "We did this because of that." Jetstone, arranged in a way that quietly solves a problem. Instead of asking what this void was for, the better question becomes, when it mattered. Because features like this don't exist for everyday life. They exist for moments when everyday assumptions break. And that's where the conversation shifts again, away from the pyramid itself and toward the broader context it exists in. The Great Pyramid didn't stand alone. Part of a way of thinking about permanence. If this kind of planning shows up here, it raises the possibility that similar thinking may have existed elsewhere, even if it hasn't survived in visible form. Not every system leaves a monument behind. Some only leave their absence. And that realization reframes how we look at ancient construction altogether. Not as static achievements frozen in time, but as dynamic responses to conditions we no longer remember. That doesn't mean the builders knew everything. It means they knew enough. Enough to plan. Enough to anticipate. Enough to hide the solution where it wouldn't interfere with daily life. Which brings us to a subtle but important turning point. If the void is part of the solution, then removing it, filling it, or interfering with it would make the structure worse, not better. And that creates a tension we're still living with. Because now that we know it's there, curiosity pushes us to explore it. But engineering caution pushes back. Some things are only safe as long as they remain untouched. And that's a difficult balance to strike. Especially when the thing in question has survived thousands of years by being left alone. At this stage, the investigation slows down again. Not because there's nothing more to learn. And that's where this story begins, to move from discovery toward responsibility. Because once you know something exists, you also inherit the question of what to do about it. And there are no easy answers when the thing you've found might be doing its job, precisely because no one ever interfered with it. That question lingers. Not loudly, but persistently. Waiting for the moment when we decide whether knowing is enough. Or whether we need to understand at any cost. At this stage, the investigation reached its most uncomfortable phase. Not because the data became unclear, but because it became too clear to ignore. Up to now, everything could still be framed as interpretation, as theory, as careful inference. But the longer engineers looked at the void, the more it resisted being treated as an anomaly. It behaved like part of the design. Design implies intention carried through time. This is where a subtle shift happened in how people talked about the pyramid. The language changed. Words like chamber and cavity quietly disappeared. They were replaced with terms like feature and element. Not because anyone wanted to dramatize the discovery, but because the old words no longer fit. A chamber suggests use, an element suggests function. And function doesn't require access. One of the most telling details is also one of the least dramatic. The void has no signs of internal collapse. No debris accumulation. No irregular deformation over time. Which means the surrounding structure has been accommodating it, not fighting it. That matters, because stone is unforgiving. It doesn't hide mistakes well. If something is wrong, it shows. Cracks propagate. Stress reveals itself. Failure leaves scars. Here, there are none. Which forces an uncomfortable conclusion. This space isn't tolerated by the pyramid. It's integrated into it. That idea is hard to sit with. Because it reframes the builders as problem solvers operating with constraints we don't fully understand. It suggests they were not just stacking stone, but thinking in terms of systems. Systems thinking doesn't emerge in isolation. It emerges when people have to deal with complexity repeatedly. When trial and error teaches them that brute strength isn't enough. When precision and restraint outperform excess. That's not the mindset we usually attribute to ancient construction, especially at this scale. But the pyramid doesn't seem to care what we attribute to it. It simply behaves according to the logic embedded in it. At this point, comparisons to modern engineering stop being metaphorical and start being practical. If you stripped away the cultural context and looked only at the behavior of the structure, you'd recognize the pattern. Load management. Stress distribution. Failure avoidance. Those are not symbolic goals. They're survival goals. Which raises a question that sits quietly behind all of this. Nods what the pyramid was built for, but what it was built to withstand. Because planning for extreme scenarios always leaves a trace, even if the scenario itself never arrives. The trace is in redundancy, in restraint, in features that only matter when things go wrong. The void fits that description disturbingly well. It doesn't contribute to grandeur. It doesn't enhance ritual. It doesn't communicate power. It just exists, doing something invisible. And invisibility is often a sign of confidence. Confidence that the system will work without explanation. Confidence that no one needs to understand it for it to do its job. That confidence usually comes from experience. Which brings us back to the same uneasy thought. What experience taught them this? Not in detail, not in spectacle. Just enough to know that something needed to be accounted for. At this point, some researchers stepped back. Not because the data demanded it, but because the implications did. There's a line where analysis turns into assumption, and responsible work doesn't cross it lightly. So instead of asking what catastrophe this might relate to, they ask a quieter question. Whoa, what would happen if this void wasn't there? The answer is surprisingly clear. The structure would behave differently. Stress would accumulate where it currently flows around. Loads would redistribute in less controlled ways. Margins of safety would shrink. In other words, the pyramid would still stand. But it would be less resilient. That distinction matters. Because resilience isn't about standing when conditions are normal. It's about surviving when they aren't. The void appears to be a resilience feature. And resilience features are rarely added casually. They're added because someone cares about what happens when assumptions fail. That realization doesn't demand a dramatic conclusion. It doesn't point to a single event or forgotten story. It simply tells us that the builders were thinking beyond the present moment. Beyond their own lifetimes. Beyond visibility. They embedded something into the structure that would quietly help it endure, without ever asking for recognition. And that may be the most unsettling part of all. Not that there's something hidden inside the Great Pyramid, but that one of its most important features was never meant to be found. It was meant to be forgotten. And now that we've noticed it, we're left with a decision. Do we treat it as a curiosity to be explored? Or as a reminder that some solutions only work as long as we leave them alone? That question doesn't resolve neatly. It stays with you, Beer, because once you see how intentional absence can be, you start noticing it elsewhere. In structures, in systems, in decisions made quietly, without explanation. And you begin to wonder how many other things we assume are complete are actually still working in ways we don't fully understand. That's where this story leaves us. Not with an answer, but with a shift in perspective. And sometimes, that's the most disruptive discovery of all. Sir, this isn't a story about a hidden room or a secret waiting to be opened. It's about something more unsettling. A structure that didn't just survive time, but anticipated it. A design choice that doesn't ask to be understood, only respected. An absence that works precisely because it stays untouched. The scan didn't reveal something extra inside the Great Pyramid. It revealed something missing. Missing things don't appear by accident. Someone decided that leaving the space empty mattered more than filling it. Someone understood that strength isn't always about adding more stone. Sometimes it's about knowing where nothing should be. That realization changes how you look at the pyramid. Not as a finished object from the past, but as a system that's still doing its job. Quietly, patiently, without asking for attention. And now that we've noticed it, the question isn't what's inside. The question is whether understanding everything is always the right move. If this kind of discovery makes you pause, even slightly, and rethink how much we really know about ancient structures, then this channel is for you. We're not here to chase myths. We're here to follow what the data shows, even when it leads somewhere uncomfortable. If you want to keep seeing what modern scans uncover when they repointed at the ancient world, you can subscribe. Not for answers, but for the questions that refuse to go away.